So we have a class here, class base, and we have a derived class, one single protected member, which we can access from the derived class itself as well. Now, what we are trying to do to have some private members specific to a class. So if you want to define something within the base itself that only will be used within the base and also not accepting children of a base to have access, then what we need is the private access modifier. So we are coming to the most restricted encapsulation. So the data will be available within the class defined only, not even within a derived class. So if we mark a member called tag here, and let's write it base. Now we can see we can access within the base class itself in the constructor tag. But if we try to access it within the derived class, it's not appear here, so we can only access X, which is the protected member. So that gives us the requirement we need, that this member here only available within the base class where we done the declaration. Now we can have private methods as well, similar to protected, and let's say something like mark tag for now, and we can just have a console log for now for the completion and say marking tag. And now here, if we try to access within the constructor, we can see still it's available. Anyway, even like if we have public method, we can access, so that proves within the class we can access it. But if we try it within the derived class, we can still see it's not available. So that's pretty much we need for the encapsulation. So that's completely restricted to the class. Now let's try to create an instance of the base class, because we define pretty much private and all this exercise here. So I'm going to create const p assign new base here. And now let's try to access the modifier outside, which is the mark tag. Now we get the error message saying here is mark tag is private and all X within the class base, which is exactly the behavior we need. But let's try to run this one and see what would be the runtime behavior. Now once you run this one, you can see still we see marking tag, which is the output of this mark tag. Now this is not the behavior we wanted in the runtime, because we want to mark this private and we are expecting it not to be used or can be accessed during the runtime. Now if it is a transcompiled version of this code, you see that's been marked as a general member in this here in JavaScript world. So it will be the behavior we would expect in a class. Now it's clearly mentioned in the documentation about this limitation. Even if you use the private, it is kind of the terminal they're using is you won't get the hard private behavior. I think what their meaning is during the runtime, the private constraint won't be there. Now that's something we need to keep in our mind. And also if it is something that's going to be important based on the application, then we might not use this private access modifier. So the other option we have is we can use the general JavaScript hash names. So in the hash names, what we do is if we want to define a private member, we use hash in front of the name. So if I mark this one hash as well, and then of course we need to change this one to be hash and here as well. And now we'll try this out again and see what is the behavior. Now if you run this, now we get the JavaScript field, private field marked type must be declared in an enclosing class. Right, so that's the exact private behavior that we are looking in the runtime in the JavaScript. So this is something we need to keep in mind. It's clearly mentioned in the documentation as well. So it's based on the application to application as well. So if you use the private access modifier, then what we get is compile time, or when you're doing the code structure as a discipline, we can use that. But if we truly need that runtime private behavior, then we have to use the hash name, which is a feature comes from the JavaScript. It's not something that is from TypeScript. So for the completion, if we go and check the JS here, you can see we're using the hashtag. And if you check the documentation, you will see how we use the hash for the private members to define the class in JavaScript. Now, imagine if we use transcompile something older version of a JavaScript, still there will be the transcompile version, more likely use a weak map or some that kind of a strategy to enforce that private behavior. So we have that guaranteed JavaScript behavior there.